Welcome to your own channel of Right Funda. Here is an interesting question from current electricity. Let's go through the question. Question says, what amount of heat will be generated in a coil of resistance capital R due to a total charge Q passing through it? If the current in the circuit, there are two cases given. If the current in the circuit, first case say, decreases down to zero uniformly during a time interval T0. And second say, if the current in the circuit decreases down to zero, halving its value every T0 second. Every T0 second, current will become half. It becoming half its value every T0 second. Once now you read the questions, now you try solving the problem. Now you can pause the video, solve the problem. After that, again you can resume and you can see the solution. Hope you have solved the problem. Let's understand the question and make the strategy to solve this problem. What the question is saying that the current was initially some value was there and current decreases to T0 0 uniformly in a time interval of T0 time. So here x-axis I have taken the time interval, a time the same, and here at the current I have taken the y-axis. So initial current was I0 was there and it becomes 0 in the interval T0, and we need to calculate how much is the heat flows. But this I0 is not given the question. What is given? During this time, total charge that passes through the resistor is Q. Q is the total charge given and time is given. Had the current been given, then we could have got it easily. So let's cut it to calculator. So what we'll do, let's write the equations like this. This current as a function of time. I'll writing the current as a function of time. So this is of the format of y is equal to mx plus c, where slope is a negative quantity and y-intercept will be equal to I0. So I write the equations of the current as a function of time h. I is equal to this, where I0 by T0 is the slope minus I0 by T0 is the slope of this graph. This is the slope of this graph, and that is the current as a function of time. So this I0 is not given, otherwise I could have got it. I0 I have taken as the I0 here, and T0 is given anyhow. So I0 to be calculated. How will you calculate? Question is saying that if the charge is equal to Q, and we know that Q is equal to I dt integration. Total charge Q is equal to integration of I dt, that we know. So that equations will write. Then if we integrate this value, we can get easily the charge is given. So I0 can be calculated. So Q0 is equal to I dt integration. Where Q0 I have taken the total charge. Q0 charge I have taken. Okay. So T0 to T0 I can integrate and I can obtain the value. But this will be a little bit cumbersome process. Integration will be a little bit 2-3 steps you have to do. But without integrating also we can do. How we can do integration? Because if we have put this one value, then we could have got the other result. Q0 and I relation we could have got. We know that I dt integration is what? The area below this graph, this area. This is the area. This is equal to I dt integration anyhow. So this area I will see this equal to base half base into height, base equal to T0 and height is equal to I0. Half T0 into I0 is nothing but my Q0. So I can write here this Q0 is equal to area below the IT graph, and this is equal to, I write the Q0 is equal to half T0 into I0. So from this, as Q0 is given to me, that is the charge that flow, I0 is equal to 2 Q0 by T0. I put a box over this, I can, so that we can use it later on this one. So we obtain this result. Now, so this I0 I substitute in my equation, then I is equal to mx minus c format what I have written. There I substituted Q value in this equation. What is the I is equal to this one place of I0 I substituted. If I substitute the value, I got this one. So this comes in the form of y is equal to minus mt plus c format. This is the equation of a straight line. Again, charge is a function like this because Q0 is constant. This is like this. So comparing this, I got this quantity is my m and this quantity is my c. The y-intercept is there. So current is equal to of this format. So if this format is there, so into y-axis what I have taken, I have taken. So I is equal to minus mt plus c. So this, and I know the heat flow I have to calculate, and we know that formula that we use is equal to S is equal to integration of I square r dt from 0 to T0. Once I got the I is equal to minus mt plus c, that I will value I will substitute, and I got this one. Once I integrate this value, I can get easily the heat flow and I can be calculated. If I integrate, then I got the equations like this. I is equal to minus mt by 2 cos cube by 3 into differentiation of divided by differentiation of this quantity. If I substitute the values, this will be from 0 to T naught, because that till the time the current flows. So this I integrated this one, I can get the equations like this. I got that heat flows is equal to H by 3 Q naught square or Q square, whatever the value I've given, the total charge that has flown by this. So this I got the answer. If the current decreases linearly, I can get the heat flows in the circuit as like this. Now we come to the second question. What second question says? We'll see the second question. Second question is that if the Q charge pass through in that time, but total charge pass equal to Q or Q naught, whatever write in. If the current in the circuit decreases down to 0, halving its value every t naught second. They're not linearly decreasing. Every time it is becoming half hour. How it is becoming half, it is not given. Question is not clear. But we assume that suppose the current flows like this, and I assume that current is going like this and current decreases like this. So I naught was there, it decreases like this. In t naught time, it become I naught by 2. Again, another t naught time, it becomes I naught by 4. Another t naught time, it decreases exponentially like this. So one of the function of current is a function of time is equal to every half t naught time it becoming half. So I can write I is equal to I naught into half to the power t by t naught. So I put t naught, I put is equal to 1. So this I can get the half to the power this t by t naught, not minus. So this is equal to half to the 1, 2 t naught time, half to the 2, 1 by 4, 3 t naught time, this by power 3, 1 by 8, and it goes like this. So if I simplify this one, I can write this value, I can substitute, and I can find the charge again can be calculated. But right now the current will not be 0. Theoretically, it will be the infinite time it will take. It will be to become 0, it will take infinity. So I have to integrate 0 to infinity to calculate the Q, because this Q has been given to us. Total charge flown has been given to us. So I can integrate this value to get Q. From that, I will get the value of I naught, which is not given the question the way we did the last time. But last time it was a linear function was there. But right now we have a function we've taken so that the charge become half of its previous value in every t naught time. So if you integrate the value, we'll get then equations like this. Q is equal to I naught t naught into ln 2. So if I see this charge I got, this is the total charge that is flown during this time. Once I got this Q naught, from this I can calculate the value of I naught. So I naught is equal to Q T naught by Q by T naught into ln 2. So this is another result we got obtained, and this value I'll substitute here. This value I'll substitute here. This equations I'll take I naught, I'll substitute. I got the I as a function of time can be obtained. So if I write the equations, then this become this I naught, I value I will substitute I naught square into 2 to the power pi naught, this I square RT, I value I will substitute, I naught value substituted, and this we integrated this value, we can put the values, and after that integrating this equations, we can obtain the values of heat flown to the circuit is equal to this into ln 2, I square into I square, here ln 2 I have not written, ln 2 square to be taken. So integrate this value we can obtain. So integrating this, we can get the value easily. And when you did here, 1 ln 2 times will coming in the denominator, 1 ln 2 time will be cancelled out, and we got these values to be equal to heat flows in the circuit. If total charge Q flows to this, and every half dinner time the current becoming half of its initial value, then this is the heat flows in the circuit that we calculated. So there are two questions are there. One is the current decreases linearly, okay, to 0, uniformly to 0 after in interval t naught, and second is that every t naught time it becoming half. Then first question answer we got the 4 by 3 q square by r by t naught, and second question answer we got the r q square by 2 t naught ln 2. Now second question says that it becoming half. Question is not clear how it is becoming half, it is not clear. Question is saying it become half. So we assume that question is current is flowing like this, because in discharging circuit we have seen sometime current flows like this. So we have assumed like this, but it may not be like this. So it may this continuously like this, may be like this, but suppose discretely current is changing. So one of the possibility can be like this. I will give you two homework to you. You calculate further. Two methods what are given, we call the answers. Suppose the current is changing like this. This is equal to I naught what current was there, and every t naught time it becoming half. I naught by 2. Again this will become equal to I naught by 4 and I naught by 8 and so on. Half it becoming and never becomes 0 like this. If this is the function is given, suppose step functions like this, then again the same problem solve and find out how much heat will be generated. T naught time mein, T naught time constant current flows, again it become half, again constant T naught time, again after T naught time again become half, and it goes like this. How much heat will be flown? Solve this problem. Another way also it become half like this. Let's see. Suppose the graph is like this. Suppose graph is like this. Here initially the current was I naught, and T naught time my current become I naught by 2, but it decreases linearly from this to half value. Again from this to I naught by 4, again T naught time. Again this to this, again T naught time will take, and this I naught by 2 times here. The slope become again lesser than this one, because here I naught by 2, here I naught by 4 decreases here. So this is this. Again it becomes like this. So this one straight line, again another lesser slant, and it goes like this. Again it will be like this, and again it will be like this, and like this. If it is the function like this, if it decreases like this, then become half, then what will be that here? So in the question, as it is not clear how it is decreasing, we have taken it is equal to e to the power I naught into 2 to the power half to the power t by t naught. That is a function of this type we have taken like this. But if this may be possible, so the two questions that you see will be finding. The next video will be again coming up with the solution of these two functions. Suppose the current decreases, how much heat flows will be there, we can calculate. Process will be same. You hope you enjoyed the video. Solve the problem right now.